We left off on number 5. So number 5 is a little different because the limit is as x approaches infinity, right? We don't use L'Hopital's rule. Anytime it says approaching positive infinity, negative infinity, we don't use L'Hopital's rule. What do? We just use the same notes, the same ideas we did back in August. I cut and pasted it here because it's in your notes from when we did limits. But this is, remember, top heavy, bottom heavy, equally distributed, that idea, that's what that is. Okay, so if you have a limit that if it's approaching positive infinity or negative infinity, think of it as, is it bottom heavy, top heavy, or equally distributed? Okay, so like number 5. The powers match, right? They're both polynomials, they both have powers, and the powers match. The biggest power, right? We don't care about anything other than the degrees. The degrees are the biggest power, so this guy here. The +1 and the -1 are meaningless when we're doing this. We're just considered, if it's equally distributed, we just consider the big powers. So it's a coefficient of the degree. A fraction of the leading coefficients. Well, the leading coefficients for here are 3 and 2, right? So a fraction of those would be 3/2. That's what we did in August, and that's what we're continuing to do. That hasn't changed. Okay, so anytime it says the limit as x approaches infinity or negative infinity, don't do L'Hopital's rule. It works, but I don't want to show you that when we already have a system that works. Okay. So this one is not as x approaches infinity or negative infinity. This is 0. This is a value. Okay. So we plug in 0, right? So plug in 0. What do we get? Then we get 0/0, right? How do we get 0/0? Well, we have e to the 3 times 0 minus 1/0. 3 times 0 is 0. Anything to the 0 power is +1. So really, this is 1 minus 1.
Oh my goodness.
So we can use L'Hopital's rule for this guy. So L'Hopital's rule says, take the derivative of the top, the derivative of the bottom, try it again. So the derivative of the top. So the derivative here is just going to be that guy, because the derivative of -1 is just 0. So what's the rule? What's the derivative for anything e to a power? Rewrite it.
Derivative of the exponent.
There you go. Yep, rewrite, and then derivative of the exponent. So rewrite it, e to the 3x. The derivative of 3x is just 3. And then the derivative of x on the bottom is 1. And let's try it again. Plug in 0. 3 times e to the 3 times 0/1. We're definitely not going to get 0/0 because we have a 1 on the bottom. So it's really 3 times e to the 0/1, which is 3 times 1. We get 3. Okay. So that's more of what we did on Tuesday. Okay, that's all we really focused on, okay? All right. We started one with trig, but now there's another one with trig, okay? So plug in 0. We have the limit as x approaches 0.
What is tan 0?
So tangent of 0, 5 times 0. So the tangent of 0, I believe, is 0. Let's double check. Tangent of 0 is 0. Okay.
We got 0/0, guys.
So we got 2 times 0/5 times 0, which is 0/0. L'Hopital's can work. So let's evaluate it at 0 with the derivative. So the top is 2 times tangent. 2 is the coefficient, so we don't have to do product rule for that guy. If it was 2x times tangent, then yeah, see if you guys can remember. What's the derivative of tangent?
Secant times tangent? Negative tangent? Or negative
No, close. Secant squared, yeah.
secant?
Derivative of secant is secant x tangent
I
x. Yeah.
definitely did say that.
I think you said it.
Secant
So
squared.
secant
So we just lying today.
Yeah.
squared,
That's
bottom is
secant zero
5.
now.
So 2 times secant of 0, whatever that is, squared,
Yeah, I think it's just 0.
over 5. Secant of 0, let's see. Secant is the reciprocal of cosine. So what is cosine of 0? 1, right?
I believe so.
Cosine of 0 is 1. So if I reciprocal that, it's still 1.
Yeah. 1.
So it'd be 2 times 1 squared, which is 2/5. Okay. Okay, so number 8. Number 8, we return back to the as x approaches infinity. Okay? As x approaches infinity. So first thing we got to do is rewrite it because it's got a power. So the limit as x approaches infinity, the natural log of x over 2 times x to the 1/2 power. Okay. Bottom heavy, top heavy, equally distributed.
Technically, it's top heavy.
So the top is a natural log, right?
Yeah.
What is the bottom considered? It's not a log. It's not an exponential, right? Because the exponent is not a variable. It's not trig. So it'd be polynomial, right? It'd be a polynomial, yeah. So it's either going to be linear, quadratic. It's actually a square root, right? That's polynomial. So on that, in those notes, we had like a hierarchy of which ones grew the fastest. Let me bring it up here. I was just looking at it. This is in your notes from last semester, but since they're not fresh in front of you, these are the ones that grow the fastest. So factorial grows the fastest, but we don't have factorials in this class. It's more of a probability. Factorials are more of a probability stats thing. In calculus, we don't have factorials. So exponentials are when the variable is an exponent. 2 to the x power, e to the x power, right? Polynomials are anything linear, quadratic, square root, anything like that, right? Third power, fourth power, things like that. Logs have logs. Sine and cosine are sine and cosine. And then constants are anything without a variable, right? So on top, we have a log. On bottom, we have a polynomial. Which one's going to grow fastest? The polynomial at the bottom? The polynomial, right? So if the bottom is going to grow fastest, it is bottom heavy.
That's when it's 0, right? Mm-hmm. And top heavy is...
So going back to our little cheat sheet from earlier in the semester, last semester, if it is bottom heavy, the limit is always going to be 0. So this one is bottom heavy, and it's going to be 0. Okay. What about number 9? Top heavy, bottom heavy, equally distributed. It's a little bit of a trick question. Not a trick, but it's not cut and dry if you look at it.
Top heavy.
It's actually going to be top heavy, yeah.
Yeah, because
Why top heavy?
Because E's on top, basically. Or it's supposed to be on top.
Yeah, this guy here, e to the negative x. Anytime we have a negative power, how do I get rid of the negative power? Either move it to the top or move it to the bottom. Well, since it's on the bottom, it needs to go to the top. So really,
is this also 1? Is that...
it says x squared times e to the x.
Is it as above 1?
Okay.
That...
So it's top heavy, right? So top heavy, we get 2 options. Positive infinity, negative infinity. That's what we have to decide. So we know the answer is going to be since it's top heavy, it's either going to be positive infinity or negative infinity. So what type of numbers am I plugging in for x? Negative, right? Very big negatives. So if I plug in a really big negative here for x squared, is that going to become a positive or negative number when I plug it in?
Positive.
Positive, squared, right? Squared, it's going to be positive. And then if I plug in a really big negative there, is that going to be a positive or negative number? Yeah, powers don't make numbers negative. Powers only make numbers bigger and make numbers smaller.
Just made small.
Yeah, it would be really small. It would be really, really small. Powers cannot change the sign, so it would just be, it'd still be positive. So it's be a positive times a positive, which makes a positive infinity.
Oh, no.
Okay? All right, so I want you to do the last one.
Oh, it's a 0, so it's fine.
Yeah, it's just as x approaches 0.
All right, so it's definitely over 0.
So do this one and we're done.
0 over 2.
All right, I know you're still working. Don't mean to rush you, but I just want to make sure we finish this one. So yeah, if you plug it in 0 at the beginning, you get 0 over 0. And then if you do the derivative of the top, well, the first part, there's 3 parts to it. It's got 3 terms. The first one is a square root.
So the one extra.
So chain rule. You don't really need that times 1, but I just put it there. Doesn't really affect anything. The derivative of the middle term, -1, is just 0. This guy's a fraction, 1x over 2. So really, it's just -1/2 x. That's really what it is. So the derivative would just be -1/2. And then the bottom is just 2x. Normally, I would like move things down, but I'm just going to plug in 0 now just to see what I get. I know I'm not going to get, or I might get 0 over 0. I think you will get 0 over 0.
Oh, no.
Let's see, we got 1/2, 1 plus 0, -1/2, times 0, I'm not going to write it again, minus 1/2 over 2 times 0. So 1/2, and then we get 1 to the -1/2 minus 1/2 over 0.
All right, I'm seeing a lot of...
So what does -1/2 power mean? 1 to the -1/2 power. What does that mean in practical terms? What am I going to do? How do I figure that out? -1/2 power. There you go. Square root, flip it. Which one do first? Whatever one you want to. I would probably take the square root first. What's the square root of 1?
1.
Flip 1, you get 1. So it's really 1/2 minus 1/2.
Oh, no.
So it really is 0 over 0.
Not again.
Okay? So now we're going to do derivative
Again.
one more time. Since we only have 3 minutes, 2 minutes and change, I'll tell you what the derivative is.
Oh, my goodness. Goodness.
So the derivative, if I were to find the derivative again, it would be -1/4, because you multiply the 1/2 times the -1/2 times the 1/2. 1 plus x, subtract the whole power, you get -3 over 2. And then the rest of it would go away, because the derivative of -1/2 is just 0
Over 2.
over 2.
All right, so I'm going over 2.
Then you plug in 0,
Something over.
and then you would get -1/8. -3 over 2 power means you flip it, cube it, square root. Which one first? Doesn't matter. You can cube it first and then square root it, or you can square root it and then cube it. It's up to you. Okay? Okay, so your assignment, only pick 8 problems. I don't care which 8 of them you do, just pick 8 of them and do them. Okay, there's 11 total. You don't have to do them all. I just want you to pick 8. The answer key is on Google Classroom. Okay? Yeah. So just choose 8, do those. Try to mix it up a little bit. Don't pick the 8 easiest. Try to mix it up a little bit. Do this one, do this one, do that one.
Of course, that was the plan.
Okay.
Yeah, work smarter, not harder.
All right, guys.